Today we're having a look at PyTestFlow. This is a Python-based sequential tester, and it's got a browser-based GUI, and it essentially lets you run a test sequence on anything really, as long as it can be controlled via Python, and as long as there's some kind of measurement that you're able to actually receive from it and test. A couple of days ago, I did a bit of a blog on this, just kind of a step through installation. So we're just going to follow this and have a look at that. The setup that we have here, the hardware setup, is a National Instruments USB-6009, and I've got a programmable PSU here. What we're going to be doing is telling the PSU to go through a range of different voltages, and then the DAQ here is going to be measuring those voltages, and if they're within a certain range, it passes. The positive here is attached to the analog input 0, and the ground is attached to the ground. Pretty basic stuff. So let's crack on then with the actual demo here. So first thing we're going to do is open up a terminal. I'm using PowerShell as my terminal here, and we're just going to literally just follow through this blog here. So copy and paste as you go. We're going to create a virtual environment. Then we're going to activate that virtual environment. Then we're going to upgrade pip. Then we're going to install PyTestFlow. I'm just going to fast forward through this. We're then going to install PySerial, and that's to communicate with our programmable PSU. And then we're going to install NI DAQ MX for communicating with our NI DAQ. Then we're going to initialize PyTestFlow. Once this initializes, we get like a little printout here, and we can just select this, copy it, paste it in here. That just sets the environment to this folder. Hardware setup, yeah, we've gone over this already. Then the code setup. So I've got a repo here for this. So if we just open that up. So inside in here, what we have is our drivers for communicating with the devices we have here. So let's look inside. I've got a bit of code here for communicating with the DAQ, and some code for communicating with the PSU, and then a config to just set up some basic COM port stuff and channels for the DAQ. Come back out here and download this. And I have it downloaded into the same folder that we're using here. Let me just get that folder open, and here, so extract all, and then we're going to just copy these files and put them into test sequences. Demo.py is the sequence for controlling the DAQ and the PSU, and then the drivers folder is just somewhere to point to look for the drivers for communicating with them. So then the next thing we have to do is start this. So PyTestFlow start. Now that then runs the server in the background, and we can just copy this URL here, stick it up into our browser, and now we have PyTestFlow. So sequential model, and then we're looking for demo, and we're going to select that, and then in the demo folder, and we'll go back and have a look at that in a few minutes, but we'll just run the test first. So we've got a setup section here, and this is initializing the DAQ, initializing the PSU, and then we have our main body of testing. So here we just check the serial number, we check the model number, enable the output of the PSU, make sure that it's actually on, and then set the voltage, measure the voltage, set the voltage, measure the voltage, set the voltage, measure the voltage, disable the output, and then we close the DAQ and close the PSU. Yeah, let's run that now. So I'm going to increase the amount of time that it takes in between steps, just because the PSU, it might not be fast enough to change from 0 volts to 1 volt in 5 milliseconds. We can just put it up to 1,000 milliseconds, and we should be able to see it on the PSU here then as well. So I'm just going to run this. Hopefully everything works. Hopefully the config is correct. Okay, so it's looking for a user input, and it's looking for a serial number 59674871. So we run that. Now we should start seeing a change here. Yeah, super. That's it. And then that generates a report. And we can see that for these guys, these are just actions. So the action was completed, so they're done. And this is an actual test where there's an outcome that can be verified. And then we have a little bit more information then on each of these steps and what's actually happening inside them. Okay, so I'm actually just going to introduce an error here. I'm going to put in the wrong serial number, and I'm going to bring the interstep delay down to 1 millisecond, and we should probably see something fail here. So let's put in the wrong one. Yeah, okay, so with the serial number, we're expecting an exact match. It didn't get an exact match, so it's a false. And then the measured voltage, yeah, it didn't get enough time to drop down from its last voltage down to 0 before the DAQ measured it, so that's also a fail. Okay, let's go back and have look at the code now. I don't think we need the terminal anymore. So test sequences and the demo. So the demo.py file is the PyTestFlow process that we just saw running there. I'll run through it now and pick out some of the kind of important bits. So here at the top we have our various step decorators that we kind of need to import. So action steps, numeric limit steps. We'll have a look at some of these now as we go through it. Then this section here, we're kind of just getting the path ready to access the driver folder and the contents inside of it. So we're kind of importing our drivers for the PSU, for the DAQ, and we're loading up our config, and we're getting the expected model number, and we're just kind of saving it as a constant here. Then we have a couple of helper functions here to keep the code tidy. So we have get user serial number. This returns the serial number that the user input at the start of the run, so the serial number that I entered in. And then we have get DAQ and get PSU. Both of these return the handle for the DAQ and the PSU. Startup steps. So the startup steps, both of these steps are action steps, and this type of step doesn't return like a pass or fail. It's designed just to kind of like execute a specific piece of code, and it also has the ability to store information that can be accessed later. This action step in particular, what it's doing is it's initializing the DAQ. So it's opening up the DAQ and it's storing the handle in this store as variable here. The PSU then is doing the same, so we're opening it up and then storing the handle. Then we move on to our main test steps. So again, here we have another action step. This time we're not storing anything, we're just enabling the output of the PSU. Then we move on to the next one. We have a pass fail step here, and that just is expecting a boolean to be returned. And in this case, I'm getting the output status of the PSU, and if it's on, that's a true, well then the step is a pass. Our string check step, this is checking the serial number of the PSU. So what it's taking as the expected value is our helper function here, which is getting the user input at the start of the test run. And then it's just asking the PSU for the serial number, and then the match is expected to be exact. Yeah, this is kind of more the same here. Another string check step. Then we've got another action step here. We're just setting the voltage to 0. Yeah, this is another important one to have a look at. Our numeric limit step. So here I'm kind of setting the bounds to minus 0.1 and to a positive 0.1. So here I've set the voltage to 0.0 volts. And then when I use the DAQ to measure the voltage, I'm expecting it to be within this bounds here. And if it's not within these bounds, well, then it gets a fail. And I just do that then for the rest of the steps. Yeah, it's pretty self-explanatory there. Then we have our cleanup steps. We're just closing the handles here. Yeah, that's pretty much it. And then finally we have our main sequence here down the bottom, and this is where we actually build the sequence itself. So we put in the steps in the order that we want them to happen. So this is our startup steps, and I've put in the steps I want to have happen in the startup inside in here. And then this is the order of operations that I want the sequence to happen in. That's about it. Okay. Thank you.